when we discussed these problems last week, one of the comments I made is to think about order of operations. And since we're solving equations, we basically want to reverse those order of operations. And this should work for many of the problems that we will work on. So when we get the exponents, since we are in radical form, don't forget from last week's discussion, we're going to turn that radical into an exponential, and then from that, solve the problems. So if you go ahead and begin problem number 1 and complete it, if you're working with a partner, go ahead and work together. And then turn the video back on to see the solution for problem 1, and then continue to work on problem 2 and so on. Alright, so for problem number 1, one of the things we talked about last week is that if I want to turn the radical into a rational, a fractional exponent, the radical, or the fourth root, gets replaced with the exponent 1/4. So if I multiply the exponent of 3 to the 1/4, fourth root of x cubed becomes x to the 3/4. That doesn't mean 3/4 times x, but x to the 3/4. We want an exponent of 1, so that means we're going to multiply the 3/4 by an exponent of 4/3, or its reciprocal. And we're going to be doing the 4/3 exponent to both sides, and that will give me x to the 12/12 on the left side, which is x to the first. And then we're going to turn the 40 to the exponent of 4/3 into an approximation. So 50 to the 4/3 is the actual answer. And then 50 raised to the 4/3. Keep in mind, always put the fraction in parentheses. And hopefully you got an answer of 184.202 for your final answer. Go ahead and move on to problem number 2 and turn the video back on when you're ready to talk about it. Alright, so problem number 2. This time we reverse order of operations. So we have a subtraction problem to undo. So you turn that into 0 by adding 25 to both sides. So you have the 7th root of q to the 9th will equal 512. If I get rid of the radical, or replace it actually, with a fractional exponent, the 7th root is replaced with the exponent of 1/7. And then if I multiply the 1/7 to the exponent of 9, q will be raised to the exponent of 9/7. So it's q to the 9/7 equals 512. To get an exponent of 1 on the q, we need to multiply both sides by the reciprocal on the exponent. So 9/7 become times 7/9 gives 63 over 63, which is 1. So q is equal to 512 raised to the 7/9 exponent. And put that in your calculator. Again, don't forget about putting the exponent in parentheses. 512 raised to the 7 divided by 9, or 7/9 exponent. It actually gives you an exact answer of 128. Go ahead and work on problem number 3. And when you are, again, ready to check your work, I'll turn the video back on. Alright, so problem number 3, we have a multiplication problem to undo. So I would multiply both sides by 6, or divide both sides by 6, or multiply both sides by the reciprocal of 6, which actually might look a little nicer since we're starting with a multiplication problem to a fraction. So 6 times its reciprocal, that's 1, so it's going to be leave me with a fraction of 1 over the fifth root of w to the negative 3. And 1/6 times 96, or 96 divided by 6 is 16. If I get rid of the radical and replace it with a fractional exponent, that will be 1/5. And if I multiply the negative 3 to the 1/5, I end up with 1 over w to the negative 3/5 exponent equals 16. Since the exponent of w is negative, we'll rewrite that so the exponent is positive. So it becomes w to the positive 3/5 equals 16. If I multiply the 3/5 by its reciprocal, which is 5/3, I'm going to do it to both sides, then the exponent on the w becomes a 1, because 3/5 times 5/3 is 15 over 15, which is 1. So the problem becomes w equals 16 to the 5/3. I'll put my calculator, and we should end up with an approximation. And we get approximately 101.594. Go ahead and complete the last problem. You can turn the video on when you're ready to see the solution. So this time, if I start at the reverse order of operations, first step I would do is add 30 to both sides to get rid of the subtraction problem and create a 0. So we have 8 root x equals 28. Next is undo the multiplication step by doing division. Create a value of 1. So square root of x equals 28 divided by 8, which is 3.5. And in this problem here, we can change the square root into an exponent of 1/2. But again, this is hopefully one of those that you've done enough practice with, that you know to undo or to change the exponent on the x from a 1/2, which is the square root, to a 1. We need to square both sides. That would make the exponent with the x now become a 1 instead of a 1/2. So we're doing 3.5 squared, and that's 12.25. As I mentioned last week, we're going to continue working with the exponential equations, or start with the radicals, and then turn them into rational expressions, and then solve them from there. Again, reversing the order of operations, you'll find generally will solve most problems correctly. There are a few exceptions where you may change the order and still works fine, but order of operations is a way of thinking about solving these equations is a good first step. Any questions? Please ask those on Wednesday, and again, we'll continue this discussion on Wednesday as well.